Okay, so how do we define the semantics? Okay, we first need to evaluate terms. Recall that this is a term. Okay, and the term is first we apply this interpretation recursively to each of the terms inside, and then apply this function constant, function evaluation. Okay. So having defined this, we can define the truth value of formula f under I. Okay. Now here note that I used the so-called extended signature. The detailed definition is actually in the handout, the reading chapter. But for now, let's just say that this signature is not the original signature, but it contains names of all the individuals in the universe. Okay, so that's why it has this superscript I. So this I having fixed what is an interpretation, I can name all the individuals in the universe. Okay. Okay. So the definition is actually recursive. Like the function evaluation, the atomic formula is evaluated in the same way. You first evaluate the terms inside and then apply this R superscript I. And the connectives here, the propositional connectives are similarly evaluated. Okay. Now, the new thing is, of course, for all and exists. So for all FW, FWI is true if F F of the formula F where this psi star, which is on all the object names in the universe, when you substitute the name for W, and you evaluate this function, under the interpretation, that returns true. So it looks a bit complicated, but basically what it means is if you want to say that this is true, then replace all the variables with object names in the universe. For all object names in the universe, when you replace it, and each of the evaluation returns true, then this we can say that this formula for WFW is true. Otherwise, it is false, of course. Similarly, for existential quantifiers, if you can find at least one object in the universe, and when you substitute for that, it returns true, then you can say the existential quantifiers are true. The reason that we use this extended signature instead of the original signature is because the original signature may not have enough names. Okay, so let's recall this particular interpretation. Okay, so let's say there is actually only one object constant A, and this is not sufficient to name all the members of the universe. So if I say exists X, P of X, whether this is true. Okay. Now, if we just use object constant in the original signature, what will happen is there exists object constant A such that P of A is true. But note here that P of A can be only P of 10, okay, because A can be only 10. So then 10 is not a prime, so exists X, P of X is actually false. Okay, because on the that restriction that we only care about object constant to be substituted for variables in the existential quantifier, exists X, P of X means the same as just P of A. Okay, and obviously P of A is false. However, that is not intuitive. Okay, exists X, P of X means that there is a prime number in the set of natural numbers, right? In order to do that, we have to use this extended signature. Okay, so when you say exists X, P of X, okay, this is true if f of say m is true for some m in the universe. Okay, so that m can be any prime number, let's say 2. Okay, so you can select it. Although 2 was not named in the original signature, okay, but you can say when you define this meaning of quantifiers, you can go over, or you have to actually go over all the members of the universe. Okay. All right, so here is a simple example. Okay, so let's just recap. This is our interpretation. Okay, you have to fix the interpretation to apply whether the formula returns true or false. So for all x exists y, py, and qx, y. Okay, what that means is there exists x such that, I'm sorry, for all x, for all number, there exists y such that y is a prime number and y is greater than x. Okay, so it means actually there are infinitely many prime numbers. Okay, because if you take any number x, you can always find a prime number that is bigger than that. Okay, of course, in terms of number theory, this is true. But how are we going to evaluate this in the propositional first order logic? So this returns true if and only if, according to the definition, okay, for all m in the universe, okay, I'm not going to actually distinguish between object names and the actual elements in the universe, so let me just write m. So all m in the universe n, okay, this formula must evaluate the true. Okay, so this I'm applying the second to the last bullet here. Okay, and then it goes recursively inside. Okay, for this one is true if and only if there exists a number n such that p of n and q m comma n is true under this interpretation. Now we can apply this interpretation here. We note here that P under this interpretation means n is a prime number, and Q under interpretation means m is less than n. So we can rewrite this thing in terms of for all m, there exists n such that n is a prime and m is less than n. Okay? In other words, you can always find a bigger prime number than any number that you choose. Okay? And this is of course true. Okay, so since this part is true, we can now say the original evaluation is true. Okay, until we reach here, we don't know whether this is true or false. So this was just if and only if conditions. Okay, but now since this is known to be true, we can say this is true.